Okay, welcome back to calculus class. We're going to work on some addition. Welcome back to addition. It's third grade calculus. Not really. Let's add sevens together. 7 plus 7 plus 7 plus, and then I'm not going to write all of these out. I'm going to write 1, 2, 3, skip a few. And then I'm going to get to a few more. So I'm going to start with, this is the first one. This is the second one. This is the third one. And I'm going to skip over to this being the 11th one and this being the 12th one. Okay, so just based on that alone, what is the total here? Well, if you know how addition works and you've been paying attention when you learned multiplication and you've had multiple reviews, you know what you can do is if you know how many sevens there are total, which you start with 1, 2, now there are 2, now there are 3, so on there are 11, now there are 12, 12 sevens added together. What that is just 12 sevens, or in other words, 12 times 7, which is 84. Now, so far in math, we really only have this as a way of representing that we're adding 12 sevens together. There is a new way of doing this now, and that's what we're going to learn. What we would do is we would represent this with the number 7, which is the thing that we're adding over and over and over again, and then this Greek letter, sigma, which is like a capital S, stands for sum. Some people put little things on it here. I'm not going to do that. It's a bit of a waste of time. And we know there are 12 of them, and notice we had to start at 1. That'll be important later. But yes, if we start at 1, that gives us 12, and we go to 12, that gives us 12, and so that's 12 times 7. So notice that this is a new way of writing 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7 all the way to 12 sevens and getting a multiplication. So let's look at a slightly different version of this. I know that multiplication is commutative, so I can write out 7 12s, and that should be the same answer. So let's write out 7 12s. 5, 6, and 7. Okay, now this is 7 12s added together. So that still should get me 84, and it does. But the way this would be written here is very different. So this time what we're adding together is a bunch of 12s. And so we are summing the 12s. And we start with 12, the first 12, and we go all the way up to, we get all 7 12s. So there really is a direction here. You do go from the lower number to the upper number, never the other way around. And so this is another way we have of writing this. Now you may notice, what do all of these have in common? Well, what we could say is that there is a common factor of 12. We'll get there in a second. First, what I wanted to point out is these numbers here, top and bottom, are basically what is being written down here. So this is the I, what's called the index. So it just helps you keep track of, if you wanted the third number, I would be 3 in this case. Or if you want I to be 5, that would be the fifth number in this case. So again, we can assign 1, 2, 3, 4, 5, 6, 7. This is just as I is going up, it starts at 1, goes 2, 3, 4, 5, 6, 7. Once you get to 7, you stop, and then you know you have written out all the 12s that you need. We can do exactly the same thing in this case, if we start with 0 and go to 6, because all we've done is we are still adding, the sum is still exactly the same. There's still 7 12s, we're adding them all together. But in this case, I starts at 0, and it goes to 1, and then a 2, and then a 3, and then a 4, and then a 5, and then a 6. And so we have still done 7 numbers, but they're called different things. It's really kind of a silly thing, but it's actually quite important. And one of the things you can see about this, that is my entire paper. Okay. 1 second. All right. So notice that for Okay, so if you're trying to figure out exactly how many there are, as I said, this is very easy if you start at 1 and go to 7. That would be the total number of things would just be 7. It's whatever the top number is. Now, if the lower number is not 1, that gets a little trickier. How would you know, say, if it was from, I don't know, -3 to 15? That's kind of tricky. You might say, oh, well, 15 minus -3. For some reason, my mouse is not happy with that. And so that's just 18. You're mostly correct. Yes, the difference between 15 and -3 is in fact 18. But the difference between 7 and 1 is 6, not 7. So don't forget that you also have to add the starting number to get 7. You don't have to add it to the 7. So you also have to add the starting number of -3 and then go from -3 to 15. And so there are, in fact, 19 separate numbers. So yeah, so with from 0 to 6, you do 6 minus 0 is in fact 6, but then you add 1 for the starting number, and that gives you a total of 7. So it's still 7 numbers. This idea is very similar to when you have something like, days Monday through Friday, because it looks like 4 days. And in fact, it isn't 4 days. So what does it look like? It looks like something like, from the Monday the 24th to Friday the 28th. And you say, wait a second, that's only a difference of 4. Yes, there are there are 4 days between Monday and Friday, but you have to start on Monday. That's the +1, the starting number, and then there are 4 other days besides Monday. In other words, it's like on a landing. You start on the main floor, and then you're counting how many flights of stairs you have to go up until you reach your desired place. This is like the difference, but you have to add in the starting floor. Anyway, so side note on that. Okay, now you may have noticed that we have for something like the 7/12s, what this really represents is 7/12s added together. Okay, this is the 7th one. And so what we can do is we can actually represent this as 12 times 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, can't we? I mean, that's just basic undistribution. You have a bunch of factors of 12. You can pull them all out to the front, and that leaves you with a whole bunch of ones. And this is, in fact, 12 times 7. But let's look a little closer at that. How can we represent this using sigma notation? Well, that would be, there are 7 of them. If you start at 1, that gives you exactly 7 of them. And it would just be sums of the number 1. And notice that that gives you 12 times 7 exactly. So what this means, first of all, right here and right here, notice that we have a constant, which is 12. We can bring that constant out front. And we just get right here. Because we can factor that 12 out of every single one of the numbers that we are adding together, we can just bring the constant out front, which is very nice. So what we can say is that for a constant c, if we have from 1 to n of c, that is in fact just the constant times the sum from I equals 1 to n of the number 1, and that turns out to just be precisely c times the number n, because remember, this is exactly how many things there are, and if you're just adding up n ones, then that's just n. Okay, so this is an extremely important piece of information for how to use sums. This is probably one of the most important pieces of information. All right, and so that is where we will end the first part of this.